my screen sharing here. Okay, now for this one, the network layer protocol and IP addressing. Okay, and this is the objective. Describe the main protocol at the network layer. So kali ini kan, you akan introduce the layer 3. Describe the concept and classification of IPv4 addresses and special IPv4 address. Okay, apa ialah IPv4? Okay, then after that, sini ialah IP network and subnet. Okay, try to understand the subnet and the IP network. Use the IP network address planning method. Okay, apa type method yang dia boleh support. And here's the content. The network layer protocol. Okay, first of all, the network layer is often called the IP layer. The network layer protocol include the Internet Control Message Protocol (ICMP). Okay, masa kita buat itu tracer atau ping kan, protokol yang guna untuk ping sebenarnya ialah ICMP. Then you boleh nampak semua IP kan, ia manage daripada layer 3 ni, network layer. So that's why we call this is the layer 3. Okay, the IP. Okay, IP is a short for the Internet Protocol. IP is the name of the protocol file with small content. It defines and describes the format of the IP packet. The frequently mentioned IP refer to any content related directly or indirectly to the Internet Protocol instead of the Internet Protocol itself. So function. Provide logical address for device at the network layer. Okay, kalau compare dengan layer 2, layer 2 ialah data link layer. Okay, so it only manage those of the MAC address. Tapi itu MAC address kita panggil apa? MAC address kan sebenarnya ialah those physical address. Sebab itu address kita tak boleh ubah. Okay, the MAC address is always fixed and you cannot change it to any other MAC address. Okay, so kita panggil MAC address ialah physical MAC address, tapi untuk IP kan, Internet Protocol IP ya, IP sebenarnya ialah logical address. Itu address kita boleh sentiasa ubah. Okay, you can always change the IP that you want. It's responsible for addressing and forwarding data packet. So the version right here is IPv4 dan IPv6. Okay, so on the yesterday, saya pun ada buat sedikit introduce about the process of the encapsulation and also the decapsulation. So the encapsulation mean daripada atas sana kan, kita punya application layer, ia akan verifikan you punya data. Okay, apa jenis data yang you guna sekarang. Then after that, they'll send down layer by layer and add the header in front of your data. Dia akan keep tambahkan header. So that's why you punya data semakin panjang. Because there are other banyak header di hadapan. Okay, so including your port number, your IP address, your MAC address as well. So at last, the physical layer will going to convert your data frame into the binary bit. It becomes the binary bit. And this is the IPv4 packet format. So IPv4 header, okay, di antara Ethernet header itu MAC address lah, okay, layer 2 dan layer 4, the TCP header. So IP is located at the middle. So when you actually expand the header, you're able to see, they will show you what is the version of this IP, the length, the service type, total length. Below is used for the TCP synchronizations. Okay, identification, flag and fragment offset. TTL, protocol, header checksum, and the most important will be the source and the destination. Okay, sebab dia perlu ada itu IP address kan, in order to understand that where is my destination and where I come from. Okay, so data packet fragmentation. The process of dividing a packet into multiple fragments is called fragmentation. Okay, ini akan berlaku kalau for dual pair, the two hosts right here, they're actually separated by one gateway. So this gateway, they actually know what is the speed for the client. When the host is sending the data to the gateway here, okay, and the speed is actually not same or equal with the host speed. So A can actually support the high speed transfer. They can send a very large data, but to the B, they can't able to accept the whole frame. They cannot. So that's why as a gateway, the router, they're going to fragment the packet into the multiple pieces. Okay, then the next, this is the TTL. Okay, time to live. The TTL field specifies the number of router that a packet can passing through. Once the packet pass through, the TTL is reduced. Okay, the TTL is reduced to 0, and the packet will be discarded. So this TTL is like their petrol. Okay, every time when they actually send to the next server, the value will be actually decreased 1. Okay, kalau dia tolak 1 kan, dan dia punya nombor saja jadi 1 kan, atau kosong, dia tak boleh pass ke next lagi. Okay, so ini ialah function of the TTL to prevent kan loop di kita punya network. Then the next, this is the protocol. Okay, so protocol is the mention that what is your next header after the IP header. Okay, seterusnya after the IP, apa protocol lekat ke sini. Okay, then the next is the IPv4. IPv4 address. Okay, what is an IP address? An IP address identifies a node or an interface on the network device. IP addresses are used to forward IP packet on the network. So now, got one man right here. The destination is IP address, IP5. So right now, they're actually on this side, IP1, IP2, IP3. So the address is actually used for the device itself to forward out the packet. So all the router have their own path decisions. So the router will base on the routing table and verify where should I forward the packet. So if it's all preferred path is on the router 2, you just connect to the router 2. Okay, same. Okay, right here the IP, they have a different subnet. Okay, then the next one, the IP address notations. IPv4 got total of 32 bits long. It's in the total decimal notations. So the example right here, the IP address 192.168.10.1 is 4 bytes. And when we convert, become the binary 1140.1010.30. Okay, so for the conversions, this one, right, they actually have one formula. So we have 2 power 7. Normally we're using this one. Okay, but after already master this one, right, you doesn't need to using this formula. When you look at the number, you already know what is the decimal for that. This is 2, 2 is 4. Okay. Hey, I'm making a mistake. This one supposing is wrong already. 4. This one supposed to put 4. 2 and 1. So this one. Okay, so this is their formula. Now, like by giving the 192, we want to know the binary. Okay, so you just put 1 right here because 128, right? 128 plus 64. Okay, 11000000. So this is the 192 because you just have to add these two numbers together. 128 plus 64 become 192. Then the next 168. Kalau 166 kan, dia pun dah susah sangat. So, boleh tolak daripada 118. 1, 0. 1, 0, 1, 0, 0. Forget the space. 1, 0, 1. Okay, then 1, 0, 1, 0, 1, 0, 0, 0. This is 168. Mengapa boleh jadi 168? Sebab kalau pergi campurkan 3 nombor ini. Okay, so 128 plus 32 is 160. And then plus 8-nya sudah sampai 168. Okay, so this is how we actually calculate. And 10, 10 ini pun tak susah sangat. So, ini tak boleh. Ini pun tak boleh. Satu. So, kita boleh masuk ini. So, you masuk itu satu di dalam saja. Then, lepas tu you boleh tambah. Okay, tambah sini. 8 campur dengan 2. Okay, ia akan jadi 10. Okay, it's actually not very hard. And the last one, I think this one you also can do it. Okay, kosong. So, this is the binary for the 192.168.10.1. Okay, dengan gunakan cara macam tu, dia ada sendiri punya formula. So next time you actually can roughly guess that what is the binary for this dotted decimal. Okay, so this is the formula. Okay, so you boleh gunakan cara ini untuk faham how to actually convert the decimal into the binary. Okay, continue on. The network part is actually identify the network. For the host, is actually identify the host itself and use the differentiated host on the network. The network mask, people also call this is a subnet mask. It's used to distinguish the network part from the host part in an IP. So sekarang mereka gunakan IP address yang sama. Okay, still the same. Okay, then you boleh nampak di sini kan, ini dia letak biru. Okay, sebab ia gunakan, okay, setiap total decimal sini kan dia ada total of 8 octet. Sorry, bukan 8 octet, 4 octet. Total ya 4 octet. Each octet got 8 bit, dia ada 8 bit. Okay, so semua campur together ia akan jadi 32 bit, 32 bit. Okay, 4 octet with 32 bit. So now, what they actually try to let us know that when kalau you jumpa kan, itu prefix belakang sini gunakan /24, 24 kan, that's mean yang hadapan punya 24 bit sini. Ini mereka akan panggil network. Okay, mereka bikin network address. So for one of the IP like this, right? How I know where is my network address and where is my host? Okay, ini ya host punya ID. Macam kita punya rumah kan. Hadapan sini ialah kita punya jalan. Jalan 5, jalan 6, jalan 11. Okay, so this is your street name. And behind here, this is your unit number. So you boleh cakap, oh, saya punya rumah tinggal di nombor 5, and then jalan taman apa-apa. Okay, so to the IP network also the same. The first one is actually referred to the network, and this is actually used referred to your unique IP address. Okay, with using the network mask. So kalau sini ialah /24. So cakap sini kan sebenarnya 24 bit hadapan ialah network kan. So then what is the subnet mask? Ini kalau nak jadikan subnet mask, dia akan jadi 255.255.255.0. Sebab kalau you punya bit ialah 234. So hadapan sini sudah ada 24 bit. So this is 24. So you boleh convertkan itu prefix jadikan something much like this. So you can see right here they got total of 24 bit. Okay, 24 bit. So that's why they were going to write in /24. Okay, hadapan sini 24 bit ialah network address. Yang last kali sini ialah kita punya unit nombor. Okay, so it's 1. And the next, the network part. Identify a network host part. Identify the host is used to the differentiate host on the network. On the layer 2 addressing, the community A is a network B. Number X straight 1 and then followed by the persons. Okay, tapi ini saya tak boleh tunjuk di dalam ESP. The layer 3 network addressing. Okay, kalau 2 itu PC kan, di subnet guna /24 sebenarnya 2 punya network sini tak sama, so we will actually require the gateway in order to perform the routing. So that's why you nampak di sini ada satu router di tengah-tengah. So PC 1 sini akan hantar ke gateway sendiri, then PC 2 pun sama juga akan hantar paket ke sendiri gateway. So why these two is belong to two network? When we look at this subnet mask, first 24 bit. Okay, and this one. Okay, you can actually notice this one is 1001. This one is 1002. So mean that's already in the different network. 102 and 101 is a two different network. If there are other two different networks, you need to configure the gateway for them to form the connections again. And this is the IP address classification. To facilitate IP address management and networking, IP address are classified into the following class. So class A, B, and also C. Okay, so kalau nak tengokkan mereka punya range sebenarnya class A daripada 0 sampai 127. For the class B, it start from 1 to 5. Okay, until 191. This is a class B. On the class C, you need to know more because the range of this one is actually very wide. But let me check. This one they do class C. The class C. 192 sampai 223. D 224 sampai 239. And last, this is actually used for research. So kalau mereka program kan yang satu teknologi yang baru kan, and they want to test run on the global. So they actually can using the reserve range for their new technology, the new protocol. So this is the classes for IP punya class A sampai class E. Okay, IP address type. A network range defined by a network ID is called network segment. Network address identify the network example 192.168.10.1. Ini ialah mereka punya network address. For broadcast, then the last host ID here ialah semua satu. Okay, sebab tak ada orang gunakan nombor ini lah. This is the broadcast. Okay, broadcast available address. IP address that can be allocated to the device interface on the network. Kalau you ada itu host punya ID, macam ni satu dari belakang kan, inilah .10.1. IP address type. Okay, sini so. Okay, next ialah calculation. What are the network address, broadcast address, and the number of allowable address of class P? 172.16.1.10.1. So by given 172.16, so this 2 is the network address. Sebab dia gunakan /16. Hadapan 16 punya nombor. Okay, so this is the network address. So that's why you can see that Sunday bus is all 1 in front, and the behind is all 0. Okay, network address, broadcast address. Okay, so you boleh nampak dekat sini ya. Okay, kalau network address macam namanya. Okay, this one is actually is what .10.1. Okay, ini ya .10.1. Okay, tapi di sini yang you nampak semua ialah kosong. When everything is actually 0, that means this is actually called network address. Okay, this is called the network address. Then when the belakang sini kan sama lah semua ialah kosong, this is the network address. But then this is actually dangerous. Okay, because it's all 1. All 1 means it's a broadcast. Okay, with this format. So you can see how they actually calculate. Use the 2 power of 16 and you dapat jawapan 65536. So that's my maximum number can be support. Then if they're actually asking about the valid range, kalau ada tanya kan, then you mesti nak tolak 2. If the first address and the last address is reserved, cannot use. So you better block this. Okay, then the next, the private IP addresses. Some IP address in the IP address space are special mean and functions. For example, special IP address, a limited broadcast address, 255.255.255 in address group. It can use as the destination address and the traffic designated for it sent to all hosts on the network. Then any IP address, this one people also will call is network route. Okay, ini boleh bawa kita pergi ke internet. It is an interface of many network addresses. In this block, refer to source host on this network. Loopback gunakan 127. Okay, ini loopback kan semua PC pun pasti ada ni. Okay, you should have this loopback. So it's used to test your software system file. Okay, kalau itu loopback itu ping, you have to replace your PC already because impossible that you cannot trace to this loopback. Then the next, link locker. The link locker is suppose it's actually for IPv6. Okay, link locker address. If a host fails to automatically obtain an IP address, the host can use IP address in this address block for temporary communication. So in another way, ini kita akan panggil API okay, API address, APIPA. Okay, then the next here is comparison. Okay, they try to compare that IPv4 versus the IPv6. So IPv4 addresses managed by the Internet Assigned the Number Authority, okay, INA, where enhances in 2011. As the last public IPv4 address was allocated and more user and the device. Okay, access to the network, IPv4 address were X-houses. So this is the big driving force for IPv6 to replace the IPv4. Sebab tadi saya ada cakap, IPv4 maximum hanya 32 bits. So that means it's around 4 million IP address. Okay, tapi walaupun saya letakkan 4 million dekat sini kan, tapi pun sebenarnya tak cukup. Okay, still is not enough. Actually, it's not 4 million, it's billions. It's billion. Oh, salah. It's billion, it's not million. Okay, 4 billion of the IP address. Tapi 4 billion pun tak cukup punya. Sebab sekarang ramai orang kan sure have one mobile and one is for the personal laptop. So one person is already used to IP address at least. So then when the worldwide people also using this range of the IP address, high chances we got so many IP duplicate in our global network. So in order to reduce this one, right, they actually recommended using IPv6 now. Let's look at the comparison. The length is 32-bit. Address type, unicast, address, broadcast, and multicast. Some of them support. Characteristic. IPv4 address differentiation in appropriate packet header design. ARP dependency include 4. So they actually really have this one. And the IPv6, the bit, when you compare on the bit, this is actually longest. 32 versus 128 bit. So this is actually super long. So impossible that IPv6 is not enough to use. And just type, it also support all. Okay, they support the broadcast, unicast, but no longer is the multicast. The characteristic, unlimited number of the addresses. Okay, simplify packet header, automatic IPv6 address allocations. So ini sebenarnya guna untuk Anycast punya. Okay, then the next content here is the subnetting. Okay, why is subnetting? A class B address is used for the broadcast domain. Wasting address. Mengapa wasting kan? Sebab kalau gunakan classful punya address 172.16 kan 00 as your network address. That means you punya preface ini kan sebenarnya gunakan 16. Okay, dua octet hadapan ialah network. Dua nombor belakang sini ialah host punya ID. Okay, if you're doing this one okay, you actually waste quite a lot of the address. Mengapa saya cakap waste? Sebab 2 power 16 sebenarnya you ada 65,000 IP address is quite a lot. And kita sebenarnya tak perlu pergi gunakan banyak address macam tu. Okay, it's not necessary. The broadcast domain is too large. Once the broadcast occur and internet network is overloaded. Okay, sebab dia punya range terlalu besar, so sangat senang generate the broadcast. A network number divided into multiple subnet. Kalau you separatekan mereka kan di dalam subnet yang tak sama macam ni. Okay, all of them is in the different group, separate by the router. You akan perasan. There are other router di tengah-tengah block. So with this one, you can able to isolate them into the different broadcast domain. So dengan cara ini kan, kalau you punya zone sini ada broadcast, dia takkan pergi ke zone yang lain. Okay, so this is how they actually prevent the broadcast problem. In this way, the broadcast domain is smaller and the network planning is more reasonable. Okay, IP addresses are properly used. Analyzing the original network segment. Okay, sekarang dia kasihkan IP address. This one is the network address. And this is the broadcast. Mengapa saya cakap ini broadcast? Sebab belakang sini semua ialah satu. Okay, so this is a broadcast for ini network. One class C network, 192.168.10.0. And the default subnet will be this 22255. So kalau dia nak kita pergi explain which one is the network address and which one is the broadcast address, this is the answer. The network address, broadcast, and total of IP address. Okay, taking a bit from the host part. Bit can be taken from the host part to create the subnet. So kita tak semestinya guna itu nombor macam /8, /16, /24. Okay, so sebenarnya it's not necessarily macam tu. Okay, kadang-kadang kan you pun boleh pinjam juga. Okay, pinjam. So like example, we know in front here got 24 bit. Okay, guna 24 kan. Sebab sini sudah ada 24 bit, 24 bit. And we feel that for the host sini kan, sebenarnya tak perlu ada banyak. It's not necessary to have so many. So you actually can highlighting, right? Like example, sini. Ada 3 yang extra punya, I nak kasih for network. Is it possible? Okay, so the answer is yes. You boleh buat cara macam tu. Okay, it's no problem punya. So like example, previously sini sudah ada 24 bit, 24 kan. Sini ada 3 bit yang extra. Okay, 3 bit yang extra. So just using 24 plus 3 is a 27. So next time you will get address here 192.168.10.0/27. This one will be your new address. Okay, sebab 3 bit ini kan sudah masuk ke depan sini. Okay, boleh punya, you boleh campur. Mengapa macam tu kan? Sebab belakang sini 5 bit untuk host sudah cukup. Okay, 5 bit for the host is already enough. So no need to waste and create the range of 2 bit for one subnet. Okay, it's not necessary. Okay, macam mana dia buat itu calculating punya kan? Sebenarnya dia ada itu. Okay, sebenarnya dia ada ini kita panggil VLSM. Okay, to saving the IP resource. Okay, kita tak bazirkan IP. If you have one zone, okay, you have a lot of PC inside. So this is the IP, the network address. Okay, network address. So kalau /24 ialah network. Okay, then berapa bit tinggal for the host? So host punya bit kan ialah 32 minus 24. Okay, it's actually 8 bits. So dia ada 8 bit untuk for host punya. Tapi perlu kita is it we actually very need the 8 bit for the host? If let's say right now di sini zone kan host ada berapa? Dia hanya ada 25 orang, 25 user. Di dalam zone ini hanya 25 orang saja. Okay? So if I using the /24, is it waste the IP? So let us check. Sekarang host bit ada 8 bit kan? Okay, then you can use the formula. Okay, you check. 2 power of 8 minus 2 equal to how many? Okay, minus 2. Okay, ini adalah jawapan. So host punya bit, ya, sini kan, dia akan masuk ke sini. Okay, formula sebenarnya ialah 2 power of n minus 2. Okay, this is the formula. So that's why ini belakang itu n sebenarnya ialah host punya bit. Okay, so you letak 2 power of host b minus 2, then you get the answer. So actually, right, if I using a Sunday mask like this one, this is my prefix 24. Kalau saya gunakan 24, that means saya punya host boleh support total of 254. Tapi untuk kita punya zone ini hanya ada berapa orang? It's only 25 user. It's only 25. So 254 is too much. Sudah terlalu banyak, too much. So now, what is the best for the host? Selain daripada saya pakai yang ini, bolehkah saya jimatkan IP address? Okay, the answer is yes. Okay, but you need to know how to do the calculations. So example now, you know that our user is actually 25, right? 25 user. Okay, so 2 power of n. Kita tak tahu kan? Minus 2. So 25 user kan? Itu nombor sini. You dapat punya jawapan mesti lebih daripada. Okay, after you minus 2. So then, what is the n bit sini? Do you know what's the n bit?
I think so.
Proper? Any other proper?
5 bit.
5, betul tak? Tengok kita tak boleh terlalu besar kan? You mesti just nice, okay? Paling dekat 25 ialah the best punya. Okay, so let's try. Kalau 5, betul tak? 2 power of 5 minus 2. Ini akan jadi 32 minus 2. 27. Betul. So, 27. So, that's mean, kalau sini you gunakan salah lah. Ini saya bingung ini. Simple. Saya terbalik itu simple. Sorry, my mistake. Seperti like this one kan. Kita punya kiraan sini kan, mesti nak lebih. Mesti nak lebih. My mistake. Okay, so must be more. So, 2 power of 5 minus 2. So, kita dapat punya jawapan sebenarnya ialah 27. Ya, betul. That's correct. Okay, so dengan itu kiraan kan, you tahu itu n bit lah. So kalau you sudah faham itu n bit kan, then you boleh buat itu VRSN calculation. So kita jangan gunakan yang original. Sebab original punya sanding mask ini kan, dia bazil terlalu banyak IP. Too much IP waste already. We want to save the IP. So now, after I get the bit 5, okay, this is 5. Jawapannya 5. So now, what happened? Kita punya IP kan sini ada 32 bit. 32 bit. So you're just using 32 minus 7. Ini adalah host punya. Okay, tadi kita, sorry, bukan 7. 5. My mistake. It's 5. Hanya perlu 5 bit saja. Okay. So then tinggal 27 bits. Ini untuk network. Ini ya total. Okay. IP address total ya 32 bit. Tadi kita punya kiraan sini kan 5 bit sudah cukup. Okay, untuk user. Okay, 5 bit sudah cukup. So that's why saya letak 5 dekat sini. So 5 for host and 27 is for the network. So next time kalau kita nak muatkan itu network 25 orang kan, jangan guna 24 lagi. We using this one. 192.168.1.0/27. This is the answer. 27. Okay, so this is how we actually doing the VLSM. Okay. Yeah, thanks. Except, you tahu saya betul kayak ini. Yeah, yes, I didn't realize that. 32. Sebab saya keep ingatkan itu prefix 27. So sini saya pun lukiskan 27. Okay, my mistake. Because the final answer is 27. So I keep thinking it's 27. Thanks for reminding me. Yeah, so this is the calculation. Okay, ini baru betul. Yeah, 32 minus 2 is actually 30. Yeah, hope you guys have no problem for this one. Because this is also one of the exam question. Dia mungkin akan tanya. Dia kasih you satu itu subnet macam tu lah. Dia kasih kan. Lepas tu, dia cakap, this network only have 30 user. Or maybe only got 10 user. So what is the prefix the something master should configure for this network? Okay, so you nak tahu macam apa itu kiraan. Okay, so this is called the VLSM. What is that? VLSM. Okay, the network is obtained, the all host speed is 0. Ini dia cakap, kalau itu VLSM sudah borrow itu bit yang hadapan itu bit, kasih yang hadapan kan, then yang tinggal sini ya host punya network. So now sekarang network ada 25 bit, 7 bit untuk host. Wah, ini panjang. Okay, maybe I will do the continuous one. Okay, let's see. Right now, sekarang dia ada satu itu practice soalan. Okay, this practice soalan. Questions. And existing class C network segment, dia guna ini IP ya. Use the VRSM to allocate IP addresses to the three subnet. Dia ada 3 subnet ini. 10, 10 dan 30. So, macam mana you bagi gunakan satu subnet ini kan? Share used by these 3 different group. Okay, how to do that? Yeah, so, ini for practice punya. So, saya letakkan dia ada 3 group lah. Okay, mungkin saya letak di sini. So, ini A. Yang besar punya dulu, biasa. Okay, A. Ini yang besar. B. And C. Yeah, group A. So, group A, kalau dia cakap ada 30 user. So, 30 user. So, kita punya jawapan sini mesti nak 2 power of n minus 2 mesti nak besar daripada 30. So, tadi kita bisa ada buat kan? So, 30 have to be more, right? So, it's 2 power of 5 minus 2. So, jawapan sebenarnya equal 32 minus 2. Okay, so sekarang kita sudah tahu itu n bit lah. Lebih kurang macam tadi yang kita buat ni. Okay, itu bit is sebenarnya 5. So kalau sekarang you sudah faham itu 5 kan, then you boleh tahu that, okay, saya punya network address ini ya, dia guna 192.168.1.0/, okay, /27. Yeah, 27, correct. Okay, so macam mana dapat 27 kan? Sebab you gunakan 32 tolak 5. Okay, yang tadi kita kira punya. Okay, this is the host. Yeah. Okay, kita dapat dari sana. So, you dapat itu /27. Okay, tapi kan, ini belum M lagi ya. Kita tahu group A kan, we were actually using this range of the IP address. This is for the group A. Okay, we know that. But you nak faham kan, ini sebenarnya lah network address. Kan, this is a network address. We also need to know the broadcast address, the last punya. So, biasa macam mana kita buat itu kiraan. Okay, untuk saya kan, saya akan buat macam tu. Normally, okay, I will using this. Okay, I'll start from how to do it. Okay, 0, 0, 0, 0. Okay, ini sebenarnya 0 kan. Okay, seterusnya, sebab saya kira sini ada 5 bit for the host. 1, 2, 3, 4, 5. 5 kosong. So, that means sekarang, okay, hadapan sini jangan sentuh, remain. Okay, masih ialah kosong. Tapi belakangan semua tukar jadi 1. Okay, you boleh dapat itu jawapan. So, kalau 5, 1 di belakang, apa tu? 1, 2, 8, 64, 32, ini ialah 31. Betul kan? Kalau ada 5, 1 belakang. If you don't believe, you can use your calculator. Calculator boleh dapat jawapan juga. Okay, binary convert to decimal. Ini adalah decimal. Okay, and this is the binary. So, ini sebenarnya lah kita punya broadcast. This is a broadcast. Okay, so broadcast punya IP address tak boleh configure untuk user. Kalau you letak 192.168.1.31 kan, dia akan come out error. Okay, because this is the broadcast address for 27. Okay, ini tak boleh guna punya. So always remember the first IP kosong dan the last IP ini kan, dua pun tak boleh guna. Okay, the first IP is called network address. Yang paling pertama, this call network address. Okay, network and the broadcast. These two cannot be used. So saya punya IP range ialah dari .1 sampai .30. Okay, this is my IP range. You can use .1, .2, .3, .4, .5. Tak ada masalah. Sampai terakhir nombor .30 pun boleh. Tapi kan jangan gunakan kosong, jangan gunakan 31. Okay? Okay, now group B. Sepuluhan. Okay, formula. 2 power of n minus 2. So what do you think? Okay, 2 power of what? Will be better.
Oh, sir. 4.
4. 3 tak boleh kan? 2 power of 3. Kecil sangat. Okay, betul. 4. Not bad, you get answer. Okay, minus 2. So 10. 2 power 4, 16. Minus 2. Betul. Dapat jawapan. So, sebenarnya ialah 4 bit. Okay, so sini ya, kita akan sambung ya. Okay, sini tadi kita dapatkan. Sekejap. Last nombor ya 31 kan. So, ingat ya, 0 sampai 31 kan, sudah guna untuk grup A. Dah guna untuk grup A. So, jangan pergi usik itu nombor lagi. 0 sampai 31, jangan guna. Tak boleh ya. So, sekarang, you hanya boleh guna itu nombor kan. Bermula daripada. Okay, sekejap. Sini, 32. Tolak 4 equal to 28. Okay, so saya punya saling masa ialah 192.168.32/28. Nampak tak? 32. Okay, kenapa 32? Sebab dari 0 sampai 31 kan sudah guna for group A. So, you tak boleh gunakan mana-mana satu nombor di sini. Tak boleh. So, kalau 31 ia the last punya nombor kan, then group B kan, dia akan start daripada 32. Okay, dia bermula daripada ini. So, ini nombor akan jadi sendiri punya network. Okay, this is my network. So, saya punya nombor ialah binary ya, 0, 0, 1, 1, 2, 3, 4, 5. Betul. So, 32. Ini ialah saya punya network. Okay, this is my network. Okay, sini dia cakap 4 bit. Okay, 4 bit untuk host. 1, 2, 3, 4. Sini. Okay, then we do 0, 0, 1, 0, 1, 1, 1, 1. Berapa? 128, 64, 32. So ini ada 32. Belakang 7, campur 8, 15. 15, 32, 47. Am I right?
Yes, correct.
Ini ialah broadcast. So, kita tepat itu jawapan. So, group B, mereka punya range IP yang paling pertama bermula daripada top 33. Nombor yang terakhir ialah 46. Yes, so this is a range for the group B. And now the last one. Oh, very long time we actually never do the mathematics for the secondary school. Ini ialah MX. Okay, ini pun 10 orang. Ini sebenarnya sama yang dengan tadi punya kan. Okay, 2 power of 4. Okay, minus 2. Okay, sure we get the answer already. So it's actually 16 minus 2. Okay, kita sudah dapat jawapan. So sure is 4 sebab dia sama dengan atas punya. Okay, sama. So sekarang 32 tolak 4 jadi 28 kan. Then saya punya name address ialah 192.168.48 slash 28. Okay, mengapa ialah 48? Sebab dari nombor terakhir for group B ialah 47. 47. Okay, ialah nombor terakhir for group B. So, group C akan sambung. Okay, selepas 47. So, that's why ini akan jadi saya punya name address for the group C. So, now, I nak tahu dia punya range. Okay, range. So, range, okay, 0, 0, 1, 1, 1, 2, 3, 4. Yes. So this is 48. 32 campur 16. Betul? So ini sebenarnya lah kita punya name address. Okay. Lepas tu dia cakap 4 bit for host. Sini. 4 bit for the host. Senang sekarang. So this 0, 0, 1, 1, 1, 1, 1, 1. And what is this? 15, 63. Betul kan?
Yes, correct.
Yeah, perhaps. Yeah, betul. Correct. Broadcast. So now, yep, we get the answer. The first address is start from 49. Last address, dot 62. So this is the VLSM calculation. Kita kan sebenarnya tak ada wastekan IP address lah. Sebab kalau kita followkan traditional punya design kan, gunakan /24 lah, sebenarnya you nak createkan 3 subnet untuk A, B dan C. Tapi /24 lah, sebenarnya boleh support 254 address. Tapi saya punya network sini kan pun tak sampai itu nombor. Kalau saya semua total kan hanya ada 50 user saja, 50 user. If I using this one, I will waste too much IP, waste too much. So that's why dia cakap boleh saya guna satu ini kan, lepas tu kongsi untuk setiap 3 group. Okay, sebenarnya boleh. So we need to know how to calculate with using the VLSM. Okay, sebenarnya kalau you tahu kan, you pun boleh bisikan ke itu Play Store atau itu mana itu website kan, pergi downloadkan VLSM calculator. Ini sangat senang punya. Okay, sekarang saya tunjuk ialah manual way calculation. Tapi if you got the apps, okay, the calculating is actually super fast. Sangat senang saja if you actually know that. Okay, I'll set this. Okay, let me show you macam mana buat lah. You can go to Google. Everything you can ask the Google. Very simple. VLSM calculator. Other. Wah, bagus ni. Practice here. I don't know which one is the best. Okay, I guna IP ni. Sampai ada berapa? Okay, sampai saya nak change ke tiga group saja. 3 change. Ada 3 kan? So first ada 30. Kedua 10. Last 10. Then submit. Then you boleh dapat jawapan. So jawapan apa? Yang pertama ialah 27. Hey, sama yang tadi saya buat punya. Nampak tak? 1 sampai 30. 33 sampai 46. Ini yang range. 49 sampai 62. Semua sama dengan yang saya tadi buat punya. So, gunakan itu calculator sangat laju. Tak sampai 1 minit user dapat jawapan. Okay, so yeah, if you know how to using the apps, no need to wasting your time and do the calculating. Tapi untuk exam, you need to know how to do the calculate. Okay, sebab exam, you tak payah buka itu browser untuk searchkan jawapan. Okay, saya tak pasti tak you boleh bawa cellphone masuk tak. Biasa exam center dia tak kasih you bawa phone punya. Okay, so in this case kan, kalau ada soalan dia suruh you buat itu jawapan for VLSM kan, then you need to know how to do the calculating already. Okay. So this is also the reason why mengapa saya tunjukkan itu manual way punya calculations. Okay, if you want, I will show again my screenshot. You can actually do the print screen for this one kalau you perlukan ini. Okay, so this is how I done. Okay, the answers. Okay, whoever have no problem on this. Okay, so if you guys have no question, I will just temporarily pause here to let you guys have the short break. Okay, so after the break, we come back, then we're going to continue this. Okay, belum habis lagi for IP punya. Oops. Mana you pergi? Sorry, my bad. Okay,